Hi, my name's Manjot Singh. I'm an enterprise architect at MariaDB, and I'm here to talk to you about backup blocks in MariaDB Enterprise with MariaDB Enterprise Backup. MariaDB Backup is based on InnoDB's crash recovery functionality. It copies your InnoDB data files, which results in data that's internally inconsistent, but then it performs crash recovery on the files to make them a consistent, usable database again. And this works because InnoDB maintains a redo log. It contains a record of every change to InnoDB data. Normally, when InnoDB starts, it inspects the data files and the transaction log and performs two steps. It applies the committed transaction log entries to the data files, and it performs an undo operation on any transactions that modified data but did not commit. Maria Backup works by remembering the log sequence number when it starts before the file copy. At the same time, MariaDB Backup runs a background process that watches the transaction log files and copies changes from it. It needs to do this continuously because the transaction logs are written in a round-robin fashion and can be overwritten after a while. And we need the transaction log records for every change to the data file since it began execution. MariaDB Backup will use backup blocks where available as a lightweight alternative to flush tables with read lock. So for example, MariaDB Enterprise has the ability to do backup blocks and have very limited locking, whereas other versions may have flush tables with read lock, which means that your database gets completely blocked while doing the backup. So backup blocks block DDL on tables while they're needed for operations such as backups. Unlike flush tables with read lock, backup blocks don't flush tables. Storage engines aren't forced to close tables, and tables aren't expelled from the table cache. So this means you can have concurrently running queries, especially selects. As a result, backup blocks only wait for conflicting statements to complete, for example, other DDL. It never waits for selects or updates to complete, as I mentioned, which used to be a major issue. So they should be brief and non-impactful, and our testing has shown up to 50,000 backup blocks per second are possible on the low-end hardware. So backup blocks use backup stages to actually work. So let's go into some backup stages. And this is going to be a bit of a high-level overview. Internally, it's quite a bit more complicated. So backup stage commands are a set of commands that make it possible to make an efficient external backup tool. So it starts with backup stage start. Basically what it does, it blocks the purge of redo log files for storage engines that need it, such as ARIA, and it starts logging DDL commands into the DDL log. And it may take a short time. This command has to wait until there aren't any active DDLs running. And what MariaDB Enterprise Backup does under start, it can now copy all the transactional tables, table spaces, the ARIA log files, and other engines' redo logs, such as InnoDB. And then the tool can call backup stage flush while copying that last set of files. So to copy InnoDB tables before we get into flush, MariaDB Backup has to start to watch the InnoDB Backup redo log and copy all those changes to the backup to be able to run the redos later during the end of the backup to make it consistent, as I mentioned. So things done by stage flush. It flushes all changes for non-active, non-transactional tables, except for statistics and log tables. It closes tables that aren't being used currently to ensure they're marked as closed for backup. And it blocks all new write locks for all non-transactional tables, except statistics and log tables. The command will not wait for tables that are in use by read-only transactions. And DDLs don't have to be blocked at this stage because they can't cause a table to be in a non-consistent state. And this is true for non-transactional tables as well. And Maria Backup under stage flush, what it'll do is copy all non-transactional tables that aren't in use, and then it will copy all new changes for ARIA log tables. At this point, data for all the old tables should have been copied except for a few system tables. Things done by block DDL. This stage waits for all statements using write locked and non-transactional tables. It waits for all those statements to end, and it blocks create table, drop table, and rename table. And it also blocks the start of new alter tables and the final rename phase of alter tables that may have already been running. The actual running alter tables aren't blocked here. So what does MariaDB Backup do during the block DDL phase? And this should be a brief DDL lock, just to be clear. It copies non-transactional tables that were in use during the last stage, stage flush, and it copies new tables created before the block DDL phase. And the file names are read from the DDL log. So the log also allows the backup to execute renames of files that may have been renamed during the backup was done instead of copying old tables. And it adds markers to the backup stream of tables that were dropped during the earlier backup stages as well, so those don't get backed up. The next stage is block commit. And this basically locks the binary log and commits and rollbacks to ensure no changes are committed to any tables. If there's any active commits or data to be copied to the binary log, it allows those to finish. And this doesn't lock any temporary tables that aren't going to be used for replication. They're not going to be backed up. But they will be blocked when it's time to write to the binary log, which will happen later. And it does lock system log tables and statistic tables. It flushes those finally and marks those closed. And when stage block commit returns, this is what's considered the backup time. So if you're looking for when was the consistent MariaDB backup time, this will be actually when block commit has completed and returned to you. So everything committed will be in the backup, and everything not committed will actually be rolled back from the backup. So what does MariaDB Backup do under block commit? It now copies the last changes to the redo log files for InnoDB and ARIA. And the part of the binary log that wasn't copied before is now copied. And then MyRock's files are hard linked to the backup directory. MyRock's has its own sort of snapshotting. So that's sort of hard linked into the current backup. And then finally, the final stage is end. And stage end basically ends the DDL logging. It does it frees all the resources, and Maria Backup copies that snapshot of the MyRocks tables as well. And if a user skips a backup stage, so if you're using maybe another tool or you're doing this manually, all the intermediate backup stages are automatically run. So you could actually just do start and end if you wanted to, and the rest of it happens in the middle. And this also allows MariaDB as a company to add new backup stages in the future, or more precise locking without causing problems for tools that were already using the current backup stages. So it's very forward compatible and backward compatible. So that's a basic primer on how backup locks work in MariaDB Enterprise with MariaDB Enterprise Backup on the MariaDB platform. Thank you.